Thanks students, hope everyone is doing good. In this video you are going to see what are the properties of determinants, what are their uses, how can we use the properties in the determinants. I am discussing property number 1. The value of the determinant remains same when the rows and columns interchanged. Rows and columns interchanged means you are doing the transpose of the matrix. Like if you take a square matrix and you transpose it, the determinant of the square matrix as well as the determinant of the transpose of the square matrix will be same. That is, the determinant of a square matrix and its transpose both give the same value. Let us take an example. If A is equal to 2, 3, 1, 5, then what is its determinant? See, if A is equal to 2, 3, 1, 5, the determinant is 10 minus 3, which is equal to 7. Similarly, you do the transpose of A and find out the determinant. Determinant of A transpose is equal to, it is 2, 1, 3, 5, then it is 2, 5 is 10, minus 3, 7. Same value we are obtaining. Like that, take a 3 by 3 matrix, determinant of A. A is given some matrix here, 2, 3, 1, 1, 2, minus 1, 3, 0, 4. Then what is determinant of A? We will find out using the determinant expanding of a 3 by 3 order. Then we got the minus 11 as the answer. Then you transpose this matrix, determinant of A transpose you find out. First transpose, then find out determinant of A transpose. Will be getting same value, minus 11. So from this property number 1, you understood that the value of the determinant of square matrix and its transpose will be remains the same. Hope you understand this property. This is property number 1. Let us go to the property number 2. Property number 2. If two rows or columns interchanged, the sign of the determinant changes. Means what? You find out the value of a determinant and interchange any two rows or columns, then interchange the rows or columns, then you get the value of the determinant sign will be changes. Let us take the previous example which was done in the last property. Determinant of A we got as minus 11 and I was taking the same value minus 11 here. Then now do R1 and R2. We say double arrow denotes that R1 and R2 are interchanging. So you get 1, 2, minus 1 will be shifted to row 1, 2, 3, 1 will be shifted to row 2. So do find out the value. We will be obtaining 11. That means it is minus 11 and then this is plus 11. So we understood that two rows are interchanged, then we got the determinant value will be sign changed. Similarly, 1, 2, 3, 1, 5 determinant is 7. C1 and C2 columns are interchanged. C1 is 2, 1 shifted to column 2. C1 column 1 shifted to column 2. And then 3, 5 shifted to column 1. So then you get the minus 7 as the answer. You clearly notice this one. Here interchanging the rows or columns. Yes, till now you have seen the property number 1 and the property number 2. Let us see the property number 3, which is if any two rows or columns of determinant are identical, then all corresponding elements are same. Means what? Identical rows or identical columns means the corresponding elements must be same. Then the value of the determinant is 0. Like you take an example 2, 3, 1, 2 minus 1, 0, 2, 3, 1. Here if you see that row 1 and row 3 are identical, corresponding elements are same. So let us evaluate the determinant. After evaluating the determinant value, you get the value of the determinant as 0. So before that you should know how to expand the determinant. That was seen in earlier videos as well as in the earlier classes. Okay, so here if you expand it and find out the value of the determinant, you get the value of the determinant as 0. So try to understand and try to expand and do it, then you will get it. Then also you see this another example 1, 3, 3 row wise I am reading. 2, 4, 4 and 1, 2, 2. If you see that column 2 and column 3 are equal here, so the value of this determinant is also 0. Then we'll go to the last fourth property, the property number 4. If each element of a row or a column has a common factor, then that will be taken as a common for whole determinant. Like for example, if you take the determinant of Ka1, Kb1, Kc1, A2, B2, C2, A3, B3, C3, K can be taken outside. That K will be multiplied not only to the row, Any column also if it is there you can take out, any row also you can take out, but it can be for entire row or entire column, not for entire determinant. Like in the matrices you have seen that in the, if it is a matrix k into something is there, we multiply for every element, but if you see the determinant, if it k into determinant of something, you have to multiply for any row or column, not for every element. Do remember. So if you to understand this one, you will have to take an example and you will have to do it. So we have seen the earlier example 1 2 minus 1 2 3 1 3 0 4 ka determinant value is 11. So we try to multiply, we take 3, multiply this. See, I am multiplying the first row with 3, so it is 3 6 minus 3 2 3 1 3 0 4 will be taken 3 common out, so it is 3 1 2 minus 1 2 3 1 3 0 4, so 3 11s are 33. So sometimes the taking common factor will be easy and it will be used in many proving questions of determinants, so it is very important. Also we can write like this. If it is a1 b1 c1 a2 b2 c2 a3 b3 c3, if you wanted to multiply constant to any row or column, you will have to divide outside of the determinant that constant 1 by k into ka1 kb1 kc1 a2 b2 c2 a3 b3 c3. Like that we have to see. This is explanation about property number 3 and property number 4. So please try to understand the property number 3, which is if any two rows or columns are identical, then the value of the determinant is 3. And property number 4 is saying that if each element of a row or column has a common factor, then that will be taken as a common factor for whole determinant. Even though in the same way, you see this last point, a1 b1 c1 a2 b2 c2 a3 b3 c3 can be written as 1 by k times ka1 kb1 kc1 a2 b2 c2 a3 b3 c3. That means if you wish to multiply any constant to any row or column, that constant must be divided outside the determinant. Thank you. So in the earlier videos you have seen that what is properties 1 to property number 4, what are the property number 1 to property number 4, and how do we use, what are the uses, like that we have seen. Now in this one we see that property number 5, if some or all the elements of a row or column of a determinant are expressed as sum of two terms, then the determinant can be expressed as sum of two determinants. Like if you see that first row of the given determinant here, a1 plus lambda 1 a2 plus lambda 2 a3 plus lambda 3. So you can rewrite this determinant as a1 a2 a3 as the first row, b1 b2 b3 c1 c2 c3 plus lambda 1 lambda 2 lambda 3 as the first row of the other determinant. Then you can write like that, you can easily find out. For this you can take an example and you can check it out. So for example, one question will be proved very easily by using this. See, prove that b1 plus c1 b1 c1 b2 plus c2 b2 c2 b3 plus c3 b3 c3 is equal to 0. So according to this property number 5, we just split this determinant into two determinants, so that b1 b2 b3 b1 b2 b3 c1 c2 c3 and c1 c2 c3 b1 b2 b3 c1 c2 c3 we get it. That means we did the splitting of this determinant with respect to the first row, so that you see this in the first determinant of this question. If you have this step, you got row 1 is equal to row 2, and the second determinant will be row 1 is equal to row 3. If you check b1 b2 b3 b1 b2 b3 as the row 1 and row 2 for the first determinant, c1 c2 c3 and c1 c2 c3 as the row 1 and row 3 for the second determinant. So since the rows are identical here in both the cases, 0 plus 0 is equal to 0. Rows are identical is one of the property we have discussed. Next, the property number 6, very important property which we use, the property number 6. Most of the cases we take the help of this property number 6. So we most frequently we use this property number 6 for understanding, for simplification of questions. For many things we use this property number 6. So try to understand it very carefully, try to listen it very carefully. If to each of any row or column of a determinant, the equi multiples of a corresponding elements of other row or columns are added, then the value of determinant remains the same. Like Ri is equal to Ri plus Krj, Ci is equal to Ci plus Kcj. If we apply operations like these, the value of determinant remains the same. Take the determinant as 2 4 3 1 2 1 3 6 5. Using as usual expanding, you find out you get 0. So now for this determinant, apply the operation C2 is C2 minus 2C1. Like this row column operations we have done in the determinants, in the matrices also. C2 is C2 minus 2C1. C2 is to C2 minus 2C1 means, so before the determinant C2 what? 4 2 6. In this question, C2 is 4 to 6. I wanted to write this column 2 as C2 minus 2C1, C2 minus 2C1. So when we write like that, what is happening, you see, you are getting 0 0 0, means it is 4 minus 2 into 2, 4, 0, 2 minus 1 into 2, 6 minus 1 into 3. See this first determinant, whatever it is there, see this properly, then you understand. 4 minus 2 into 2, 2 minus 1 into 2, 6 minus 3 into 2, so that you get 0 0 0. So since entire column is 0, the value of the determinant is 0. Using the property without expanding, we can say the value of the determinant as 0. These are the properties we use in the determinants. When we use these properties most frequently, and when we do the help of these properties while proving the determinants, we will be thorough with all these properties. So practice is very important for these properties. Once you practice, then you will understand where to apply, when to apply, what property to be applied, needed to be done. Thank you very much.